Hi, hello everyone. Welcome to our webinar series. My name is Natalie Steinauer and I'm the research coordinator for the Beanform Partnership. And I'm joined today by our wonderful IT specialists, Michaela Wilson and Nicolas Arias. So in the last months over our webinar series, we have highlighted our different programs. You might have joined us for a webinar on the survey or Sentinel program, and the tech transfer team have also showed us how they diagnose diseases in the field. But we really wanted to kind of turn the spotlight to our IT because none of what we do in the field or in the lab would really be possible without their support. So we are the Beanform Partnership. We are a nonprofit organization. We actually, the work began in 2011 as a CAP grant funded by USDA and NIFA. And by the end of those 5-year grants, we became sustainable and we registered as a nonprofit. Funnily enough, the requirement to become sustainable was actually part of the grant, and apparently we're part of the only few ones that ever take that small letter clause seriously, but we did, and we were very excited to succeed in that endeavor. And so today, as a nonprofit, our funding comes from multiple streams, but mostly our participant beekeepers who pay for services. We as well we receive donations, and we are still actively pursuing research grants so that we can sustain our research projects. So our mission is to improve honeybee health. And we really believe that the best way to do this is to provide valuable information to beekeepers so that they can take informed management decisions. So we usually say that we really act as a bridge between the science and the industry. So our goal is really to provide scientific information related to bee health and represent it in a meaningful and practical way. And so while we were doing that, we were collecting all of that data over the years. We kind of like became the US largest repository of colony health data. And so today, what we will show you is through these different programs and what we do, we show you what the database looks like, what the type of data we gather, and how we streamline that data collection, how we process the data, and we disseminate our results. So the whole process. And then particularly, we really wanted to take the chance to show you what that you can access the data yourself. And so a good portion of this presentation will actually be a live demonstration where we're going to show you our research platform and how you can access the data. So again, this slide shows a bird's eye view on our different activities and programs and projects, and we've covered some of them in our past webinars. But essentially, no matter what the program is, what we do is really we collect information, we summarize it, we try to give it context, and then we give it back. And so our different programs are kind of adapted to the type of collaborators that we're working with. So with large-scale beekeeper, we work particularly with them through our tech transfer team, which are our consultant in the fields. Our Sentinel program is really more addressed towards smaller scale beekeepers and bee clubs. And then we also work sometimes with researchers directly to coordinate field trials in the field in real world operations. So in each case, really our specialty where we came in is we are a specialist at monitoring and documenting honeybee health. So documenting honeybee health, colony health, disease loads, and all of that monitoring and documenting is really our specialty. So through all of that, you will see we mentioned IT product as one of the things that we do. Is really technology just kind of became unavoidable. And so the next slide shows you a picture that was taken by one of our friends. Oh yeah, I forgot about that. Okay, so I'll go back to the poll in a minute. But so this picture was taken by one of our friends that shows that this is typically the type of equipment that our field specialists take in the field with them nowadays. And you can notice the tablet that's there. And we started like everyone with Datasheets and pencil, and we still use them mostly as a backup. But more and more we are using technology to try to ease the whole flow of the data. But and it really helps streamline and speed up the whole process. So yes, going back to the poll, we've talked about some of those programs, and so we just wanted to start with knowing from our audience if there is any of you that actually already participate in one of those BIP programs.
We usually try to get up to 80% responding, so we'll give it a few more seconds here. Okay, I'm going to go ahead and close the poll and show our results.
Yes, so it seems that the largest fraction of you are beekeepers, but not participating currently in any big programs. So we hope we can convince you to join some of our citizen science programs. And then about 20% of you are not beekeeping at this time. And then the people that are part of our program currently, 10% are part of the Sentinel Apiary, 23 of the Mite Check, and 13 of the Hive Scale programs. Thank you for joining us. And okay, so what are we doing with your data is where we're gonna go next. So, we talked about the fact we collect data, we summarize it, we give it back. So that's the general flow of the data, right? But we as you can see from our different programs, we do have multiple sources of information, and the way to really categorize it is, well, first, later in this talk, we're actually gonna talk about some monitoring technologies that are directly associated with the hives themselves, such as the Hive Scale program that some of you are part of, and which Nicolas will talk about more later on in this presentation. So that's one way to collect information directly from sensors attached to the hive and to link that data directly to our database. So another way is beekeepers will answer questionnaires and interviews about their practices. They will tell us about the practices that they employ in their operation. And so this typically is done through questionnaire-based, question and answer type of data collection. For example, our loss and management survey is one of those where every April we ask beekeepers throughout the United States to tell us about what was their practices over the past year. So that is one way that we collect information as well. Then, of course, beekeepers and our own field specialists will conduct field inspections. So they will actually open colonies and document what they see in opening those colonies and doing their inspection. And so we collect information about those. And then, of course, sometimes some of those are associated with actually physical samples. So those could be samples of bees that will be processed for pest and disease, such as varroa and nosema load. We can also take samples of bees to perform viral analysis. Sometimes we take samples of pollen or bee bread to do pesticide analysis. So all of those samples, will be basically sent to the lab for processing. And so that means that this lab can sometimes be University of Maryland, which is our main diagnostic lab for pest and disease loads, but also sometimes a completely external lab. For example, when we send those pesticide sample, we typically work with a national standard lab like AMS. So every time that information is sent out, we need to gather that information back. We need to centralize, we need to merge it back together where applicable to really try to make sense of it. So once the data is in the data frame, we clean it. And that's actually probably like 80% of our work, and it's really boring. But it's really important because really it's what is needed to try to make sense of it. And then we can summarize it, and we can visualize it, and then we can basically provide that information back to our beekeepers in a meaningful way. So to do that, we will create reports, and Michaela will show you some of those reports. And really the idea is to provide context, provide meaningful information so that we don't just give you a number out of the box, but that we can compare that with past results, with other participants, and really put yourself into context. And then, of course, the beekeepers will get, if they provided an inspection and samples, they will get their own data back in a personalized report. But then we also try to gather all data from all the participants, try to really get to the bigger picture. And so that is where data modeling comes in. And when we do those data visualization on a larger scale, we share that information, we display it in our research platform so that they can really benefit all stakeholders without displaying any personal information. So it's all a matter about summarizing the data across participants so that no personal information is shown, but everyone can benefit from the data that has been gathered through our citizen scientists and our participants. So each of the arrows on this graphic kind of shows you a step in data transfer or data processing that one way or another we have tried to improve using technology. And so the advantages are really clear because we gain in reproducibility, we reduce the errors due to retranscription. Cleaner data is definitely easier to analyze, so we gain in time there. And really that allows our field technician to focus on diagnostic. It allows our lab technician to focus on on their techniques in the lab. And so, you know, it's really helped us streamline and speed up the whole process. So our IT, they usually describe their job as making our job easier, but I think you can get the picture now that this is really an understatement. So now I'm going to pass it on to Michaela to describe the database itself.
Okay, thank you. And so we'll go look at the database here in just a moment. But first, I want to talk a little bit about how we ended up with this IT platform that we have. And as Anali mentioned, there's a USDA NIFA CAP grant, and NIFA is the National Institute for Food and Agriculture. And these CAP grants, the CAP stands for Coordinated Agricultural Project. And so the idea of these programs are to bring together, they're very large grants. They bring together multiple disciplines and many different cooperators. There's more cooperators, of course, than is listed here. But these are the 4 that were kind of mostly involved in the IT section. And the Appalachian State University group is led by James Wilkes, which is the computer science department, and also the Grand Valley State University with Jonathan Inglesma is a computer science department. And I work with the University of Tennessee, originally recruited out of the Information Technology Office here at the University of Tennessee, where I was working on a CAP grant that came before this one. And these 3 grants were kind of new USDA efforts to address colony losses that started occurring in 2006, 2007 with the events of colony collapse disorder. And so our charge during all that time was to bring multiple disciplines together to address colony loss. And our approach has been, with the Beam-Informed Partnership, it's been an epidemiological approach. And we, as part of one of the objectives, was to bring in data from separate databases together into a single platform. And that was has multiple purposes. One of them is so researchers can look across these different data sets and try to make sense of them together. But from just the IT standpoint, if we, for example, build a technique or method to display data in visual maps, such as we see here, then we can apply that method across these different databases and show and reutilize that technology over and over. So it's much more efficient to have these databases working together. And in the original grant, well, when we go to look at the database, we're going to see some of these panels on the home page. And these panels are kind of representing these different sections of the database or different data sets within the database. And I selected these ones to show because they were kind of part of represent some of the original ideas in the first grant, to where this colony loss survey was going on before we created the Beam-Informed Partnership. It was coordinated with the Apiary inspectors, and we picked that up and brought that into this project as it involved some of the same people that were doing it before. The Sentinel Apiaries program, which we see a map of, that's another section. That was an initiative of the grant to collect this new data, a new way of collecting data across the country to get this idea of what is happening in apiaries as a kind of a sentinel apiaries. The APHIS reports is we'll look at more detail, but that's another database that was the original idea to bring together. We were also working with NASA and with the first grant with Wayne Nasias, who was doing hive scale work with hive scales and climate data and climate change data. And that eventually turned into what is now kind of the hive monitor section, which Nicholas will talk about later. And then we have, just data from various honeybee labs, such as David Tarpey's at NC State, where he did quite a bit of viral analysis with the tech teams early on, and that data that was part of that specific project was incorporated with our virus map. So we'll be looking at all these, and just want to give you an idea of how this came together. So let's just quickly go over there real quick. Let me do a little maneuvering here to get us to the database. And I think most of you are probably mostly familiar with our web presence at the beinformed.org site. This is our blog site where we, you know, advertise talks and have blogs. But there's many links to this database on this website. And if you go down the bottom, you're going to see some links to the database and some of these different sections of the database that you can go to. But just click on one of those, and it's going to take you to the colony loss map, the losses across the United States as part of our survey, you know, going back many years, 2007 and 8. But no matter where you're at on the database, if you want to go to the home page, just go to this little icon up here, the BIP logo, and that'll take you to the home page. And if you scroll down, you see these panels we were looking at. Again, kind of just showing you the major areas that you can look at. Up at the top, we have a login, or you can register for an account. But at this time, you really only need to register for an account if you're going to use the hive monitoring section of the database. If you just want to look at the data we have publicly available, you don't need to log in. You can link from down here or use this menu. And we're going to look at this BIP database overview, first of all, just to kind of, this is simply just to give you an idea of what are the different types of categories of data that we have in the database. And so we have a lot of Varroa and Nosema data, and the pie chart kind of splits it out into among the 128,000 measures of Varroa levels in colonies. These are kind of the different programs that they're coming from. They're coming from Mite Check, Sentinel Apiaries, Tech Team Field Techs, and just give you an idea of, you know, what data is represented here. Same thing with Nosema. You can click on these pesticides. It's a smaller pie, but a huge amount of data we have about pesticides. Over 16,000, you know, detections, I believe is what we're recording here, of different compounds in colonies. And we break it down here. There's wax samples, there's bee bread samples. Sometimes we can do trapped pollen, get an idea of what's coming into the hive, or sometimes people will analyze bees for pesticides. But anyway, again, just kind of gives you a brief look at what we have. And then the rest of these are kind of, sorry about that, are can be kind of, are going to be similar to, let's say, the APHIS reports. Let's look at this database and data set in more detail. A lot of times we're going to be displaying a map, and in this case, this map is mostly here to kind of give you an idea of what states we have data from and what years we have data in the APHIS database. And so you can select these different years, and these are going to be interactive charts. The chart will update. And here we're kind of showing the average Varroa level per state, which isn't incredibly informative because they can be taken at different times of year. That's going to influence the average. But again, it's mostly just to give you an idea of what data is available. And if you click on this state, for example, we'll say I'll go to Pennsylvania in the year 2018. It's going to, you're going to be able to drill down into the data and get more detail. So now we're looking at data from 2018, just the state of Pennsylvania. And we have these various charts that you're going to see, in other places as well, to where we're charting the average Varroa level throughout the year. And this black line is the kind of the national average. What is that seasonal trend that we can expect the varroa levels to be, and so that's, as you know, as you would expect, kind of going into the fall, we have higher varroa levels, and typically we start in the year, and then we're comparing in Pennsylvania of that year, the samples taken, you know, was that higher or lower than average? How did that look compared to the average? And that's what these blue bars. So you'll see a lot of that kind of analysis on the website. Same thing with Nosema here. The APHIS database has a large amount of viral data, molecular analysis data. And again, you know, you can kind of see what was the prevalence of, say, deformed wing virus in Pennsylvania compared to what is the common things. And so you can see that, you know, the most common viruses, deformed wing virus A, deformed wings B, Nosema ceranae, of course, is not a virus, but is a molecular target. And then these more rare viruses, such as Israeli acute paralysis virus. Here, you know, what is the average level of that? I should mention the APHIS database is designed to monitor for invasive species, such as viruses that we don't have. So we're testing for viruses here that are rare, and trying to get an idea of, are they spreading across the country? And we're also testing for invasive species mites, such as Tropiaedops mites that are not occurred in the United States, but one of the goals of APHIS is to monitor for these invasive species. And so if you've seen things on the news about murder hornets coming in, you know, APHIS is in charge of monitoring for those. We aren't actually looking for murder hornets. We only look for, the people we work with only look for species within the hive, and the murder hornets are outside of the hive. But to give you an idea, that's the kind of role that this database plays. And in this case, we give actual, you know, the actual data that's being collected. In May in Delaware County, 2018, you can see what those samples results were, what pesticides were found, and all that kind of thing. And I could spend a lot more time on this area of the database, but I don't want to do that right now. We're going to be posting a blog that gives you more detail about this, and there's a video. So let me go back to our presentation. We could spend quite a bit of time just looking at that data. Okay. So that gives you an idea of where it is. There's the URL if you want to go straight to it. And we looked at the overview and the APHIS. And there's another, if you're interested in the APHIS project, there's this other website too that we help manage, the US Honeybee Health Survey.info. And we do that in coordination again with the Apiary Inspectors of America, who collect a lot of this data with some of the field techs that we work with. And so, you know, we're collecting a lot of this data from individual people and sometimes businesses, and no matter if you're, you know, just a hobby beekeeper or a business, we are responsible for protecting private information. And so I just want to say a little bit about that, because we do take this very seriously. First of all, most of us work for universities, and there's a number of laws that we must follow that deal with PII, personal identifiable information. But it's also the right thing to do is to, you know, say, for example, in the honeybees, if someone was an inspector or working with a beekeeper, and they found that you know, working with the beekeeper to handle a serious problem like American foulbrood, and if you know, that could be very damaging to a business. And even though it's quite normal, I mean, not common, but it is normal to have, you know, American foulbrood occurrences, and if you deal with them, they will go away. But, you know, people can have a bad impression about, you know, a person or a business if you release that kind of information. So it's the right thing to protect people's identities. And it becomes a lot more complicated than I think a lot of people realize at first. Sometimes we get criticism for not sharing enough data, although we do share quite a bit of data through the database portal. But we have to be careful about what data we do share, because the definition of this identifiable information is really any representation of information that permits the identity of an individual. So it's not just an email address or a name. It can be, you know, the number of colonies and locations. If you know much about the industry, you could potentially identify who these people are. So anyway, we just keep all locked down on all that. And there's on our beinformed.org site, this link here, we'll get to some more statements about protecting that data. And let me go there. Okay. All right, now I'll hand it over to Natalie here.
All right, thank you, Michaela. All right, so Michaela demonstrated to you the APHIS data that is present on our portal, which is the this program as which we're collaborating with, but is really coordinated through University of Maryland and APHIS with the help of Apiary Inspectors of America. Now, we wanted to show you some of BIP's program as well. And so this is the National Loss and Management Survey, is probably our oldest program, as Michaela mentioned. It actually started before BIP was created with the help of the Apiary Inspectors of America. And so once we took over the program and we're running it every year, it basically is a questionnaire in which we reach out to beekeepers across the United States every year in April to report to us the number of colonies that they managed in the last year, as well as their management practices. So I'm just showing that we have a lot of collaborators that are helping us spread the word, because this is a voluntary based survey, which means that every year we have to go over and ask for participation. We usually get about 4,000 respondents or more every year. So that's about 10% of the beekeepers in the country. So we're very proud of our response rates. And if you have participated, thank you. And so this is basically the source of the information where we get our loss estimate. So you might have heard about this number that on average every year, 30% of the colonies will need to be replaced at some point in the year. We call that a loss rate. It is really a mortality rate. It is not a population decline or size of the population estimate. This is just basically how often do colonies need to be replaced over time. And we have been doing this survey for a number of years now, and so we can basically see that there is some sort of cyclical nature to loss rates. So some years are worse, and then some years are slightly better, knowing that slightly better still mean on average about 30% of the colonies will need to be replaced, which is still considered by beekeepers themselves to be high and probably not very sustainable. This last year's result, the 2019-20 results, were actually released in June. And we have just this week updated the state map. So you can find your state loss estimate for this year, as well as all the previous years, on our Data Explorer 2. So if you go to research.beinformed.org/loss map, you will be able to find state level estimates of the loss. So basically those mortality rates by states for the season of interest, summer, winter, or annual. We calculate loss two different ways: total loss and average loss, and we can explain. We will explain to you on that website, the difference between those. And so you can basically see all the historical data of the loss estimates on our research portal. So now the longest part of the survey is actually the follow-up of the loss survey, which is we call the management survey. And so this is the part where we ask beekeepers to give us information about the management practices that they've employed during the year. And if you've taken the survey, this is the part that's very long, but we thank you for all the information that you provide. And so the idea is that once we have loss on one side, and we have the mortality rates on one side, we have the management on the other. From there, we can really try to associate what is the difference in risk of losing colonies across groups of beekeepers that use one practice or use another. So we're basically contrasting beekeepers into groups based on their practice, and see what their associated loss rates were. And so that has given us some insight as to trying to identify pest management practices for US beekeepers. And when you can actually look at those results yourself using our Data Explorer, you can pick a question of interest, and then you can see the number of respondents that have answered one way or another, and you can filter, actually, you can filter to the year, the region, and the type of operation of interest. And then you can see the loss rates that are associated with each of those practices. So we wanted to demonstrate that by actually using a question of your choice. So in the next poll, we're going to ask you what data you are interested to see, and then we'll do a demonstration with that data.
Let's try to get up to 75% responding. Give it another few seconds here. Okay, we'll get up, we're at 68. I think we'll close it here because I don't know that other things are going to take over at this point.
All right, so it looks like we're going to look at the use of viricides and losses associated. Michaela, do you want to take over?
Okay. Okay, so as I said, get back to the home page, and this one, management surveys, right here. And I'm sorry, what was it Varroa? Is that what use of Varroa
Yes.
products?
Okay. So
Okay.
use Varroa treatment. So the probably the first one first.
Okay, so like Nali was saying, on the side here's the different topic areas we have something for, and you got the state, operation size, year, products are listed up here. We're going to just look at all operations, and maybe we just want to look at the last 3 years. And got Amethyst checked. And so you could look, any product use would be all. Natalie, you want to tell them about our results now? This is any product use.
Sounds good. So basically you then see a couple of graphs, right? So let's start with the bottom one, this respondents ratio, which you see those two bars, half blue, half black. So those shows you the proportion of respondents that selected one answer or the other. So in this case, for example, we see that in the number of responses, so the number of beekeepers is pretty much super close to 70% of them actually used one of those selected products that we selected above. So 70% of US beekeepers in those 3 years of our respondents have used one or the other of those products in their operation, and 30% have not. Now we also show you the total colonies managed because, no two beekeepers own the same amount of colonies. So this is kind of the idea that from our estimate, it means that over 85% of the colonies in the country have received a treatment from one of those products in those years. So you can see how that can sometimes differ, the respondents and then the colonies they represent themselves. So this shows you the respondent ratio and how prevalent those practices were. But then just above, you can actually see the loss rates that were associated with those operations. And so in this case, for example, we see that the operation that used one of those products reported on average 37.6% loss, compared to the operation which did not use any of those products that reported an average loss of 50%. So 1 on 2 colonies being lost. And then you have more details on the table below, which actually gives you the actual sample size, the estimates with their confidence intervals, and then the number of colonies that they represent, as well as I believe the mean number of colonies that each of those beekeepers manage. Right. So as you said, as you could see, there is a lot of those questions that are available on the platform. So we really recommend you to go and have a look at that data and explore it by yourself. So now the next things that we wanted to show was some of the programs with which we actually collecting samples. So you can go back, Michaela, to one just quickly. So there you go. Thank you. So the Sentinel Apiary program is one of those citizen science monitoring program. We have participating beekeepers. The Sentinel is actually mostly targeted to small scale and bee groups. And the idea is to really try to break the barriers to establish a good monitoring system. We're trying to help beekeepers establish the habit of monitoring their hive, inspecting their hive, taking samples, and monitoring throughout the season. We actually believe that the good practice is to monitor for varroa every month during the active season, because varroa loads can change so drastically, so rapidly. And so we will basically provide in this project all the equipment needed, as well as instructions on how to perform the samples. And then the beekeepers will actually do the inspection, collect the samples, and send the samples to our lab, where we process it and give the results back so that they get their disease loads. So we really hope that this project is a way to encourage beekeepers to just get into the habit of monitoring and realizing that this is very valuable for their operation, that they can get a better insight as to what's happening into their hive, they can take better decision. And then on our side as well, this is very valuable information, because we get to see the evolution of the same colonies for multiple months. And so that is very tremendously helpful in terms of research to be able to identify what drivers are affecting varroa disease loads. So this is the big kind of like summary of the program. In the Sentinel Apiary, it is a fee-for-service program in which beekeepers that participate can either sample 4 or 8 colonies, again, every month during the active season, which is usually about 6 months. So you will receive all the equipment needed, as well as instructions on how to do it. It is also associated with kind of a, every time you do a sample, you get to do the inspection and fill inspection sheets. And so what we ask the beekeepers to monitor during those inspections is really exactly the same type of information that our field specialists take in the field, because we believe that those are the best health estimates that you can take at colony level to give you a picture of what's happening into the hive. So that will be the queen status, whether the queen is present, if you see her or not, but if you see eggs, meaning that she's present, even though you haven't seen her. Those are all the type of things that we actually are training our participants to do the same way that our field specialists do. Root pattern, frame of bees, all of those I'm going to talk about in a minute. So those are all the inspection colony data that our participant will take. So then, yeah, so the next program that I'm going to talk about, and I really wanted to put the two in perspective because they're very similar and different at the same time, right? So, sorry, our tech transfer team, so there are basically a large-scale equivalent plus one-on-one consultation with large-scale commercial beekeepers. We actually have teams, we have 6 field specialists that are working in the field. We usually call them our boots on the ground, and they're working very closely with 110 commercial beekeeping operation. And so if you go back to the map, sorry, Michaela, I didn't want to go ahead. So they're working very closely with over 110 commercial beekeeping operation, which actually altogether manage more than 50,000 colonies. So our field specialists have this rare opportunity to see a lot of colonies while they're doing their inspection day after day. And so you can see that they're also this kind of a migratory force where they will follow colonies and beekeepers as those colonies move throughout the country for pollination services mostly. So our field specialists follow the colonies, and they usually typically do about 4 inspections per year for those commercial beekeepers. And it's usually very inconvenient time for the commercial beekeepers, right? It's whenever we think that monitoring needs to happen at very critical times. And so monitoring can sometimes come in the way, but the advantage of monitoring really surpass the amount of time that you will spend monitoring. So we can't stress enough the importance of keeping an eye on what's happening in the colonies. All right, so next slide. As I said, this is basically the type of services that our field specialists provide in the field to our participating beekeepers. They will do colony inspection, they will do diagnostic and consulting. They are very adept at identifying diseases in the field, and we have shown some of those in our past webinar. They will also provide additional testing on request, such as hygienic testing, particularly with our queen breeder participants. And they can also sometimes react to emergency visits and provide, very speedy consultation. And they also participate in our research trials, which, as I said, we are working more and more with researchers to basically just establish field trials in real world operations. So most of our field specialists are also part of that. So I wanted to talk about Sentinel and Tech Transfer team in parallel, because as I said, the information that they gather when they open a colony is very similar. And we talked about some of it, but this is typically the type of fields that we gather every time that we do an inspection. We look at the colony configuration, which is basically the size of the boxes, the equipment itself. We look at the queen status. We look at the frames of bees, which is this estimate of the population of bees, right? It's kind of like the number of workers in the colony and how full the colony looks and is, and if the bees are really covering the whole frames. And so this is our estimate is in frames of bees, because we don't count bees individually. Sometimes we record weight, which is kind of this other measure that will inform us about the productivity of a colony, the amount of weight that it put in during honey production and all of that. We can also look at brood pattern, which is an estimate of how compact and fill brood patches are, and it's usually an indicative of if the brood pattern is really patchy, it sometimes indicates issues which can or cannot be associated with the queen. Sometimes it's other issues such as diseases that can create a bad brood pattern. So this is something we look at as well. And then just generally, our field inspections of field specialists will look at signs for disease and pests. Of course, in addition to taking actual samples, they will look for signs of those diseases in the colony, which sometimes provide extra information as well. So I believe that from here, I'm passing it on to Nicholas to actually shows you how we are collecting all of those health metrics that provide information on honeybee health.
Thanks, Natalie. So all of these observations Natalie just mentioned need to be recorded. Our initial approach was to use paper data sheets, and here you can see an example of what these data sheets look like and how they would look like when filled. But the reality is much harsher than the examples we're showing here. The main problem with the data sheets is that they are at the mercy of the elements while in the field. So they can get dirty, they can get wet or blown away or even burned by a misplaced smoker. And although they achieve what they were designed for, they can be really messy and require extra work to get the information into our system where our researchers can make use of it for reports and analysis. So around 4 years ago, we set out to build an app to make our field specialists' life easier. They need a data entry tool that works with them instead of getting in the way. It has to be reliable. It has to be easy to use and able to interact with our research portal, even though an internet connection is not always available. The BIP research app has been one of the most important tools in our field specialist toolbox for the last few years. We're constantly improving it so that it becomes an extension of themselves while in the field. And we also want our Sentinel participants to take advantage of our app as well. So over the past few months, we have been working hard to bring all the capabilities of the research app to them. Starting next season, they will be able to use the same tool BIP professionals use a large-scale sampling for their Sentinel columns. They will be able to get the Sentinel sampling data to us much easier and much faster. And along with the app, we'll enable a way for them to get access to the reports and data through the research portal, making sure that they get their results back as soon as we have them available. I will hand it over now to Michaela to talk more about the reports.
Okay. So yeah, I think we have some Sentinel participants on, so I guess we'll go on a limb here and announce that perhaps before the season's over, you may have that online access to your own data through you get some more detail about it before the app is ready next year. But you can actually get to some of your data there right now, and we share an aggregate of that data to the general public that any of you can go look at and see. And so on the research portal, this is what the overall map is. It's similar to the one we showed before, where you can select different years of data, and here we see which states have data, and if you click on that state, then you get down into some more details about it. Again, looking at in that state, was the average level higher or lower than the kind of the national trend? What were those results? And if you have one of these Sentinel kits, they come with these codes such as SARK. And so you can look up your data on the website now, looking for that code. And again, in aggregate form, we're not sharing any of the personal information about it. But as a Sentinel participant, you also get emailed a report that is specific to you and your data and has more detail about what was found. And the database that we've looked at here is where all these reports generate from. And before we had the database, very early in the grant project, reports were created in Excel by the field techs that were going out and collecting data. And they were emailed that way. And so a big part of the database is it was automating that process to where, you know, it was just the database generates these reports, and then we email out thousands of we have emailed thousands of reports out. And here's an example of a Sentinel report where you get some tabular data showing the individual colonies there listed compared to some national averages, and we do this highlighting anytime there's like a Varroa level that's higher than the threshold of what you really want to be seeing. Here's a example from a tech team report. These reports, you know, we want the data to be actionable. So you're, you know, for management, what management are you going to do? And a lot of times, you know, beekeepers, we need to treat our colonies for the Varroa mites. And when do we do that? And how do we do that? And what products do we use? These kind of decisions should be based on what is actually going on in your colonies, not a schedule that's, you know, that nobody can come up with a schedule and work plan of treatment that is going to work across the board in all situations. What we recommend is knowing what your levels are and responding to those. And in this example report, on the bottom axis here, we have the number of Varroa mites per 100 bees. These blocks you can think of as kind of average levels, with the line being the actual average, and you have some, you know, variation there in between. And the individual points are the individual colonies levels. And so over time is on this axis, and these different inspections, you can see in your data there that this average level is going up, and, you know, some response needed, some management is needed in there to bring them down. This is again from the Sentinel report. These bars we see is again the national average, giving you a comparison. The blue line is a threshold level that you don't really want to go across. And I'm familiar with this data because it's some data I collected in the Sentinel program. And I can tell you what we've seen time and time again in the Sentinel program is treatments will often occur and start occurring in the July, August areas when I began treating these colonies, and my Varroa level just kept going up right through during the treatment period, and took quite some time before it started to go back down. And so this is why monitoring is so important, and you have you know how to respond right then, but also now I can look back and say, you know what, if I started treating in here, this was probably already getting above this line, and it probably, once you get a higher level of Varroa and then you start treating, it's a little bit too late to bring things down quickly, and so you're going to get these big peaks afterwards. We have another chart there that breaks it down by colony. Again, so you can see, was that average just because there was one colony with real high levels? No, there was a lot of, high levels there. But, we did bring them down-ish there towards the end of the season. Same kind of chart for Nosema. The national trend is that in the spring, you can have these higher levels of Nosema. 1 million spores per bee, which is right here, is kind of generally considered as it's starting to get to be a high level of Nosema. And I had some colonies above that there, but just on their own with no treatments at all, it dropped down into the summer. And that's quite common, as you can see by the national average of what happens. So, treating for Nosema is a personal decision. I tell you that I don't, and didn't in this case, and you can see what happened here. We also offer, various ways to do viral testing, or it may be done as part of a research trial. But anytime it's done, we try to get the reports to the beekeepers so they can see what their results are. And as Natalie was saying, we try to put those in some kind of meaningful context instead of just, in this case, this was a test for deformed wing virus, and it was a positive sample for deformed wing virus. Well, deformed wing virus is quite common. So what does that mean? Well, was it a high level of deformed wing virus or low level? And so we kind of rank the sample compared to other samples in the database. So along this axis, we have over 4,000 positive results for deformed wing virus. And 25% of those samples are at this low level compared to the rest of the data. This line keeps going up way higher than that. But this particular sample in this example was kind of, right here between 50th and 75th. So kind of a higher level of deformed wing virus there. Pesticides can be tested for, as mentioned before. And this is an example where, 6 different pesticides were found in a sample. Is that a bad thing or a good thing? What can we say about it? Well, in this case, there were these trace or low levels. And in our database, we have these numbers called LD50, which is the lethal dose that kills 50% of the bees in a test, in some test that was published somewhere. So we can get those numbers from the literature and compare them to the detected amounts and come up with these hazard quotients, which is like a relative risk assessment of, how bad is this for the colony? And in this case, as far as what we can tell, the hazard quotient is very low. The total is a 2. So we can kind of say it's, we found these 6 different things, but they seem to be at low levels. It's probably not affecting the colony as far as we know. We don't really know, but this is what we do know. And another example here, 8 pesticides were found in a sample. Here we have, in this previous sample, we had chlorothalonil was found. In the second sample here, chlorothalonil was again found, but at a higher level. It was found at 3,870, and our LD50 is 40. Our lethal dose is 40, and it was found at almost 4,000. So it gets a hazard quotient of a higher level, and we color it red there because it's above kind of threshold we've determined. And so we can say with this, well, yeah, we found these things, and some of them are kind of at a high level. It could be of a concern. It's all the information we can kind of give. In these reports, we also, if we have information about what these compounds are or how bees may be picking them up, that comes in the report as well. So we try to give that context, not just a number. And so there's lots of different ways to sample colonies and different things. And Nicholas is now about to talk about another way. Ooh, I'm sorry. I got things floating around here. All right, take it away.
Okay, so if you watch our top 5 worst and best practices webinar, you know that our top recommendation is knowing what your mite levels are. So with Mite Check, we want to encourage beekeepers to test for mites more often and share those results with the beekeeping community. We want to emphasize the importance of mite monitoring and show how easy and quick it is to do so. So Mite Check was originally a solution for gathering data collected using powdered sugar roll test kits developed by Marlos Vivak and the University of Minnesota Bee Squad. And it has since expanded thanks to the work of Megan Milbrath from Michigan State University and Jonathan Ingleson's team at Grand Valley State University with an educational lab. Currently, you don't need a kit to participate in Mite Check. Just monitoring for varroa is the only requirement, no matter what technique you use for it. So you can fill the Mite Check survey using either our app or the website. But I encourage you to install and use the app, which is available for both Android and iOS devices, because it provides you with functionalities other than the survey. In the app, you'll find guides for how to properly do alcohol washes and sugar rolls for varroa monitoring, along with the shake trainer for sugar rolls and other related tutorials. So if you see our Mite Check map, it will give you a context at a county level, showing the highest number of mites per 100 bees that have been reported in the current month for each county. This should give you an idea of what beekeepers close to you are experiencing. But keep in mind that seeing your county with a red color is not a reason to panic, nor seeing it green is a reason to stop monitoring. These numbers just give you a worst case scenario among the people who have sampled. And it's very important that you take your own samples of your operation and see how it's doing. Please reach out to your local beekeeping community and figure out what the people with the lowest mite counts are doing and help those with the higher mite counts. If you see a county with a gray color, that means we don't really have data for it. And that's because the map is built thanks to citizen science. So if you're in one of those counties, please share your results, use the Mite Check app or the website, and encourage others to do so as well. Another program we have is called the Hive Skills Program, and it originally started at NASA as the Honeybee Net project. And it had the goal of identifying nectar flow cycles and find variances across the country and within states over the years. So this project ended at NASA in 2011, but it still lives on at BIP with the Hive Skill programs. So for us, it is an effort to consolidate Hive Skill data from different vendors in order to make it readily available for researchers to analyze. It's a great complement to the Sentinel program since we're able to get more comprehensive colony data for analysis. And participating on it is just as simple as getting a Hive Skill from one of our partner vendors and enabling sharing with BIP. So we're always actively developing improvements to the program in order to increase its usefulness to you through event predictions and alerts. We currently have 5 BIP ready, go back, Michaela, please. Yeah, thank you. So we currently have 5 BIP ready Hive monitor vendors whose products have been vetted by the Bee-Informed Partnership for quality and reliability, and that directly integrate with the research portal for data sharing. And these vendors are Arnia, Solution Bee, Wi-Fi Hive Skill, Broodminder, and Hive. So if you own scales from one of these brands and you want to share your data with BIP, you need to enable data sharing on your vendor websites. It varies from vendor to vendor, but all of our partners have an option somewhere in their settings or enabling data sharing with BIP. Here on the right, we see an example of how to do so on a solution scale. If you go to our research portal, you can visualize your own data and add annotations to the timeline and record any noteworthy events that explain changes in weight. So maybe you're adding or removing boxes, so maybe you're harvesting honey or your colony swarm. And you can annotate that data on your timeline. So here you can see that the external temperature is the blue line at the top. Then you see at the bottom, underneath it, the black line, which is the weight, and a few annotations. So there are a few, the annotations are the orange bands, and there are a few here you can see that are just honey flow, those changes in weight because of nectar flow. There's an instance where bad data was sent from the scale. Another one where we added a super, so it increased the weight, and then there's another one where the weight decreased a bit because foragers were leaving the hive. So right now we're using these annotations with machine learning models in order to predict when something happened. These predictions are shown in the graph as the green bands you see on the right. And the user can decide to annotate them because they're important, or just dismiss them because it's just, it was kind of a mistake by the algorithm. Our plan is to expand these models to be able to tell the difference between events. So the system won't just tell you that something happened, it would also tell you what it thinks happened. And we aspire to eventually be able to let you know when these events require your immediate attention, such as when we detect that your hive might be absconding or that it has swarmed. All of these machine learning models need a lot of examples to learn patterns, so every annotation you provide us with is extremely valuable to us. We also have a map. So each hive scale user can decide whether their scales data is public or private. And these public hives or scales are placed in a map. You can click on them to see their temperature, humidity, and weight graphs, along with any annotations their owner has added to them. And we also calculate the average weight loss or gain for each state in the past 7 days. And we display that as a heat map. So redder means a higher loss, and bluer means a higher gain in weight. And you can also click on each individual state to see the weight change over time, along with Varroa and Nosema data to compare with it. So using these two functionalities can be used for getting context about how your own colonies are doing compared to other colonies in the area, or how the state is doing as a whole. That concludes pretty much our presentation. So now I would like to ask you, outside of monetary constraints, now that you know about all of our programs, which one of them would you interested the most to participate in?
All right, this is our last poll. Let's try to get those numbers up. Let's see if we can get to 75%. We're at 62. We'll give it another 10 seconds here. Okay, we've had it on about a minute, and we have about 69% responding. So let me go ahead and share those results.
Okay, so it seems that we have spiked your interest a bit in some of our programs, and that was really the goal, one of the goals of this talk. And I'm really glad we made it, and we can't wait to hear from you and your participation. So in summary, we have BIP programs for all kinds of beekeepers. Some of them are free, some of them have an upfront cost, but I'd say the barrier of entry to some of them it's really low. So we hope you can participate on them, because your participation is really valuable for not only for BIP, but for the whole beekeeping community. And we also try to make our data available as much as we can without while preserving your privacy. So you can look at everything we have available and explore and analyze it yourself. And finally, as BIP's IT team, we're always looking for new ways to support our main goal of improving honeybee health through technology. Yep, that's it. Thank you for participating in our webinar, and thank to all our sponsors and collaborators. I'm gonna hand it over now to Net for Q&A.
Great, thank you, Nicholas, and thank you, Michaela and Natalie. That was excellent. And like I said at the beginning, these are our unsung heroes here at BIP. So I'm excited to be able to showcase them today and show you all what our IT and technology opportunities are. We got a few questions in during the presentation, so let me open those up. The very first question came in at the beginning when you were showing some maps. This person is in the UK, wondering if we collect data outside of the US.
We do have some data from outside of the US, mainly Canada, but we also have some from some European countries. So yeah, we do have them. Unfortunately, we don't have a way to see them in maps, at least that I know of. But we're working on expanding our visualizations to include everyone that really participates.
All right, this came in during the survey section. What is the annual loss of wild honeybee colonies? How does annual losses by beekeepers compare to natural losses?
Right, so this is an interesting question. We are the survey is targeted at beekeepers in the U.S., therefore manage honeybee colonies. So our objective is to really try to follow the mortality rates of managed honeybee colonies in the U.S. There is no real agreement as to if there is sustainable wild European honeybee colonies in the U.S. Because it is mostly a managed species, which sometimes escape, like swarms can go out, but we're not exactly sure of how long those swarms will actually survive on their own. If they do survive multiple years, they typically don't survive more than a couple of years because of the varroa pressure. Now, that being said, we are not collecting data on all the other non-honeybees, so we are really specializing on managed honeybees in the US with the survey.
Great, thank you. This next question came in during the pesticide data. What is the range of hazard quotients, and does each pesticide have a different range?
So hazard quotient was a tool that was developed by scientists to try to make more sense of residue levels, because the problem when you just get the level of a residue level, you don't know what to compare it to. So the idea is to compare the exposure, the residue level that we have found in our sample, divided by the toxicity. So how toxic is the substance, right? Because if you have a substance that is a very low toxicity, you can be exposed to higher level without risk. But if you have a substance that is a high toxicity, a low dose will already be a risk. So basically doing this hazard quotient is a way to relate the exposure to the toxicity. Now, it is a little more complicated than a simple ratio because, and so that's why we have thresholds. Because I believe that technically 1,000 is what is considered to be the concern threshold. And that is because it is based on the amount of pollen that a bee will eat during a lifetime compared to the LD50, which is, as Michaela explained, is a measure that is done in the lab under specific conditions. So according to the amount of pollen that a bee typically eats during their life, when you see a residue level in the colony, we divide that by the LD50, and then the threshold that we're trying to see if it's below or above 1,000 is typically what the level of concerns are. And those thresholds it's a simplification of the whole issue. LD50 is usually also based on adult toxicity, right? Where they're looking at adult bees, they're not looking at larvae typically when LD50s are studied by toxicologists. So it is an imperfect system. It is one way to provide more context about pesticide data. And we're always trying to do that, to try to use the more up-to-date methods that scientists are using, but this is not perfect by any means. No, the range of LD50, the range of HQ that we see, again, is extremely wide. And that's kind of the problem with pesticide, is that you see everything from very, very low risk to very high risk. And also, but the proportion of those are very uneven, right? We see mostly low HQ, and then sometimes you can see one very high HQ, and it kind of looks like this outlier because this is typically what we have seen with pesticide. Is typically when you have a problem, it's very agglomerated. So you can have very high level in very, very few cases. So this is why trying to make sense of it is important. So that's the hindsight we have, is that the distribution is usually very wide, but it's also uneven. Most of the cases, the result that we see are not concerning. And then there was a couple of cases where they are usually very high. But again, very, very few of them. That's typically what we see. And you can, as I said, the result for APHIS pesticide samples. So APHIS, as part of their monitoring, they do 10 samples of pesticide in all the participating states every year. And those data are a part of our research protocol. So you can look at those residue levels on our website.
Thank you. And this one, I believe, also came in during the pesticide data. If you're treating with Apiguard, does it skew the data since it's a thymol gel?
It's a very interesting question. So when we look at pesticide inside hive matrices, and we can look at pollen, most of the time we also look sometimes at wax. Those are, if it's bee bread, and bee bread and wax, those are inside the hive, which means that we are more likely to actually find miticides residues as well. And so you can look at the breakdown of the pesticide that we find in those matrices, and miticides are part of the pesticide that we find in a hive. So we know that using miticides in a colony is it's not trivial. It has consequences, it has limitation, it has drawbacks. None of us are using chemical intervention because we think that there has no consequences. Usually the alternative is much worse, right? And we know the damage that varroa can have on colonies. So yes, you will find those miticides in some of those samples. So depending on what you're interested in, if people are interested in looking at pesticide samples, the type of matrix that you use is going to give you different insights. So if you're interested in seeing the outside contamination, using pollen trap at the entrance of the colony will probably give you a better picture of what's coming into the colony on a very small window of time. Looking at bee bread inside of the colony will give you probably a wider period of time because that pollen has been accumulated for some time. And then wax is usually what gives you, the longer period of time, because pesticides are known to also accumulate in the wax. So it will usually gives you, a more long-term picture of what your hive is exposed to, but as well from pesticide coming from outside, as well as the pesticide you might apply in your hive as well.
Great, thank you. A couple questions about hive scales. So someone writes in that they're really interested in the data that we're collecting and perhaps using it in a course on data science and environmental science. Is any of the data downloadable as raw data? Particularly interested in this hive scale data, but any of it could be interesting.
Currently, hive scale data is not downloadable in a raw way. I would suggest contacting us directly, and we can discuss the project and what data we could share with you that way.
Yeah, and that's a great answer, Nicholas, for all of those data that are not aggregate that people are interested in. As Michaela had mentioned, there's a lot of privacy limitations. And so we would need to work carefully with you if we were to provide any data. And so you would need to contact us directly for any of that. Okay, a second hive scale question. Mellifera is a site that works off of broodminder sensor data. Any comments on their tools?
Well, broodminder has BIP's seal of approval, so it went through our certification process. That's really all I can say about it.
Okay. And another question, how can more it looks like somebody is already playing with our Data Explorer, which is exciting. During this, this came in toward the end. How can more management survey answers be processed and displayed, specifically all feed products? Microbial options shows inaccurately only 33 responses over all of the years. We know that the number of beekeepers using microbials commonly can be referred to as probiotics, pro-DFM, super DFM, numbers in the thousands. Is it the lack of information in the National Management Survey due to lack of processing of survey answers? And how can this be improved?
I could answer that one. So in the management survey, I have a number of selections that you can select from as far as what management products you're using. And that list has changed over the years, kind of depending on what's commonly used. And then there's a way to enter free text. And we do quite a bit of processing text analysis of trying to come up with or see, what it is that people are entering in there. And so we have a pretty accurate representation of what is being entered into the survey, but the survey is going to be limited to who takes the survey. And so it's a representation of the national usage of these different products, but obviously, not everyone answers the survey. So I would encourage all of you to think about different beekeeper groups you may work with and encourage them to participate in the survey and let us know what things people are using.
All right, one more just came in. Have you explored or considered any activity monitoring technology?
Is that like bees moving?
We're in real time. Let's see if we can get a follow-up to that question.
Like I'm thinking maybe entrance counter. Is that...
Yeah, I guess it might.
Yes, entrance counters. Okay,
yeah.
They confirmed.
So, well, in our opinion, we haven't really explored that option, and we don't really think that the entrance counters can give us that many or as valuable information as we would like for the effort. So no, for now, it's not in the plans to include that into our analysis.
It seems to me that a lot of the entrance counters and different things of bees motion. That's really an area of research and development within honeybee science, and you can there's papers published quite, you know, going back for a while now on different ways of like counting bees coming in and out of the hive and things like that. And so the hive scale portal, for example, or some of these other integrated technologies we have, they're really more designed for something that is ready to be widespread. I mean, these a scale is a simple concept. You know, what is the hive weigh? You could apply that across the landscape and have very comparable data. Whereas with the entrance counter, there would be lots of different variations in the technology and what people are doing with those. And so it's probably, you know, not quite ready for something to be broadly distributed like that, in my opinion.
Okay, it looks like we've finished up the Q&A. I'll interrupt myself if I see any last minute questions coming in. But I want to thank again our presenters today. I'm very excited that they were able to share this information with you all. I want to thank our audience for sticking through us. Some of you have probably been on many of our webinars, and we appreciate our repeaters. We are going to start another webinar up in the fall. This will be our last one for the summer, as I mentioned before. I would like to put a plug in for our organization. We are a nonprofit, and if you're interested in supporting us, you can do that at beitform.org/donate. I hope you have a very successful rest of your season this year, and we hope we'll see you all again in the fall. Thank you so much.